Welcome to this session about the future of AutomationML. We have interesting things to show. I believe we have introduced interesting new concepts towards the next generation of modeling and exchange of engineering data. Before I dive into the concepts, I would like to have a short statement about the current state of where we are today with AutomationML. AutomationML is a vendor-neutral, standardized and independent XML data format for engineering data. It is object-oriented, so it follows a type instance model. It's easy and quick to learn, and I know this, I teach it. And for instance, the programming of AutomationML I teach in a single 90-minute lecture, and in the next week, in the next lecture, we do the examen, and it works fine. It scales for small and large applications. You can use it for classes, for teaching and educational purposes, as well as for bigger things with thousands of objects. It works nicely. It's low risk because we have no dependency on technology, on tools, on databases or on companies. It is all file-based and everything is in the model. I want to emphasize this feature, and just by a little story. My own diploma thesis in 1995 I wrote with a tool that is no more existent. I cannot open the file anymore today. It's fine for me, but if my diploma thesis would be a factory, then I would have a problem with my old documents. Being not able to open documents is a risk, and we don't have this risk here with AutomationML. It's guaranteed that you can still read it in 20 or 30 years because it's file-based, it's XML-based, and you have no dependency. AutomationML provides multi-language support for modeling in different languages. It has version management, traceability. It has a multi-file structure to split files and to reference external files as documents, PDFs, pictures, geometries, and so on. It is specially designed for iterative data exchange, and the tricky work on data exchange in engineering are the iterations. It's not done by just export and import. We have features for signatures, and therefore we can protect our libraries against manipulations. It's a language which helps you to build the models you need, so it's future enabled because all the data models we don't have in AutomationML you can build up with the means of AutomationML without extending or changing AutomationML. AutomationML is a multi-purpose tool. I frequently hear stories from process engineering guys who claim, oh, AutomationML is from Daimler, that's factory automation, it's not our business, we can't use it. And vice versa, I hear from manufacturing automation, oh, AutomationML, there is CX inboard. This came from process industry, it's likely not a tool helpful for us. That's all wrong. It's completely not tied to any domain. You can use it for automation components, for technical systems, for object networks. Nice for engineers, but it's universal. You can model family trees, organigrams, address books, patient records, inventory models, and whatever. And we have used AutomationML and CAX to model DIN, IC, or ISO standards to make them digital. AutomationML itself is an IC standard, and it interconnects different existing data formats that have already been thought through. We try to combine and to build bridges between existing formats, and therefore the architecture is very, very lean. If you look into the architectural part of the IC norm, it has a size of about 34 pages in the normative part. And you can build hierarchical object structures like this, and you see immediately this follows what you know from your folder structure on your hard disk. It's very common and very useful, and you can break down any kind of structure you can imagine with that. The members of the AutomationML community are shown here, and they all have developed and they all use AutomationML for one purpose. The original purpose was to improve data exchange in engineering. Especially in engineering, we don't have common data models. We still print the data out and we submit the sheets of paper, or in best case a PDF or an Excel sheet, to our partners, and they have to retype the data, and they lose data, and they invest time, and they lose time, and they lose data by reinventing things that have already been went through. That's a problem, and AutomationML tried to solve this in a generic way. But AutomationML is not something like MP3 or PDF. Just having AutomationML exporters and importers software alone is not sufficient. We need a little bit more. As a ground for the syntax, we use XML. For the standardized object modeling language, we use CAX. So far, so good, but still not sufficient for payload at data exchange. And then the tricky point is we need domain models. For the purpose of data exchange, we need a domain model where tool A and tool B agree on. And this is, of course, domain specific. only when we have those domain models built with the object modeling language CX, then we can do the payload. Then we can do the data exchange that saves money, that saves cost, that improves quality. And this is a tricky point. Here we have some news to report. There are lots of application examples for AutomationML. It's used in a wide range of industrial applications. And together with 50 co-authors among the AutomationML community, we have written the industrial cookbook, 600 pages in English, with ready-to-go recipes to utilize AutomationML. And one of my favorite examples, just to pick one, is the SCD diagrams. As you know, Equinor is the biggest company in Norway. They put the oil from the ground. They build oil platforms. And because oil platforms are large and big and complex, they thought about how can we simplify life by standardization, and they invented the SCD diagrams. SCD diagrams are a mixture of control diagrams and P&I diagrams. And still, they print it out and they sent it to the automation teams to make use of that, and they retype the data manually or with a little bit help of OCR. This was the state of 2018, and then I got in contact with Equinor with the question, can we improve the situation and can we do it with AutomationML? And within days, we developed the digital model of the existing SCD standard and developed the corresponding exporters and importers, and we transported a demo file with 1,000 elements and were able to present this on Friday. A couple of months later, Equinor put this topic into the contracts and asked Siemens and ABB and Kongsberg Maritime and others to support this, and that's the way how it got into business. So it's a very clean and very lean and very, very smart solution to overcome data exchange by PDF. Another example is the IC 62424. This standard has been developed to standardize the graphical layout of these PCE requests. They come from process industry. But we thought, why should we just only standardize the graphical representation? Shouldn't we standardize the digital representation of that? So we developed a neutral data format for general digital object models, which is CAEX, and we modeled a library with each of these elements in classes, and we have put all these attributes into a digital model, and we're able to digitally represent the standard. Using this library means being compliant to the IC 62424. And this was a challenge for the standardization committee because we were the first standard with a digital counterpart. And I remember that time that the DKE was thinking about, how can we distribute this model to our customers? Should we put a CD into the standard, or should we have a download link on our DKE homepage? This was new to them. Years later, the idea of bringing PCE requests into a digital model came back, and in a committee we developed the so-called NAMO container, which is a more comprehensive object model for PCE requests, and it's a ready-to-go object model for PCE requests. But the difference to the Equinor SCD model is that they have never put this digital model into the contracts. And this is, from my point of view, a key success factor for digitalization. If you have a comprehensive data model, put them into contracts. Everybody is willing to read them and to make use of them as long as they are in the contracts. Otherwise, we tend to use what we know, and we know PDFs. So, and one of the key questions is how difficult is it today to build AML data models. So, and here I have something that surprised myself. I asked ChatGPT, create an AutomationML document according to CRX3. And within that, an attribute type library with the name Pascal lib. And in this lib, please create attribute types for 10 typical physical parameters, please with a unit and a description in English. This is what I submitted to ChatGPT, and then look what happened. What you see here is a correct attribute type lib. He selected the parameters he believed that would be useful. And encouraged by this, I added the command, please do it again, but now please every attribute type should have a version 1.0.0. And instead of redoing the job, he went back to the already existing lines of code and added the version number. And then I asked him, please now add a unique identifier to all of these different types, and he did as well. That's really, really nice. Currently, I'm not aware of any digital representation of SE units in the standardization market, so that was really astonishing. Meaning creating data model has become so easy, so easy. And ChatGPT is not the reason why it's so easy. It was already easy before. Computer scientists know this, but the result is that it's a mindset. we tend to redo rather than to reuse. Software engineers and IT guys are so progressive, they prefer to reinvent models because they don't even know where the existing models are. Where can I find the SCD model? Where can I find the Namo container? Where can I find all these digital models? It's not easy. So in the result, we get isolated model silos with a variety of data models. We reinvent existing models again and again. We get a variety of semantics and ontologies. We have no standardized methodology to master this diversity. We have no interconnection method. We have no bridging mechanism between these semantic standards. If you find a solution, then it's usually proprietary, non-standardized, or expensive. And to counter this, the key approach is just standardization. We need committees for the standardization of terminology, semantics, ontologies, for metadata models. But we reinvent metadata models, ontologies, and semantics again and again, and we get in conflict. The not invented here syndrome is really everywhere. So we develop local standards, company standards, de facto standards, competing standards, and we have the DIN, IEC, and ISO standards. And there is one weak point in all these digital data models. And the core weak point is that there is a lack of distribution mechanisms and solutions for a clever reuse of existing data models. A very shiny example of how to do it is OPC-UA. OPC-UA's major business model is the distribution of data, therefore they don't have this lack. But all the other data models we use in engineering typically suffer from this lack. They have no distribution mechanism. But distribution is the basis for efficiency. It would be the basis for bridging semantic diversity. What would we need? We would need a methodology to provide models to others, to make them searchable, findable, and to make these models machine understandable. We need a concept that is manufacturer independent, technology open and standardized, and will still work in 10 years. We need something reliable. We need something that is suitable for business, from open source to hardcore business models. We need something that is sustainable and stable. We need something that supports versioning, signing, mechanisms for updates. We need something that adapts to the different workflows in industry, from single user to team use. We need the capability to select the technology overhead that we need and to replace it by a new technology overhead next year. So we do not want to be addicted to a certain technology overhead. It should be suitable for small and medium-sized enterprises. It should be accessible to single-person companies. And it must be PhD-free. And it should be low cost. So this is what we strive for. In Germany, we in 2013, we forced all petrol stations to submit their prices to the cloud in real time. There is one cloud where all the different petrol stations store their geolocation and the current prices of the different petrol kinds. And based on this, apps appeared to make value out of this. Lots of apps like this available that show me where the petrol stations are, and where I am and how can I get them and where are the prices and about the history of the prices. That is helpful and that is useful. The basic pattern is always the same. You have, number one, you have a physical world. You have, second, a cloud representation of interesting data that represent the physical world. And then you have algorithms and apps that make value out of that. And this is exactly what we miss with data models. The weak point of all information models is the ability to distribute and to version their data. Very nicely, we can model automation components, and there are very nice and different device descriptions available. In society, we currently create models for the digital citizen. The hospitals have models for the digital patients. The process industry has digital representations for P&I diagrams like DEXP. Companies have digital models for customers. German BAföG is a very interesting story. If you want to have governmental support, financial support for students, you can apply for that, and you do all this digitally, but in the end, on the other side of the screen, it's printed out. There is no digital continuation behind that. Our administration, they have digital models, but they are all incompatible among other countries and among different domains. And even our norms and standards are still mostly available in paper, and it's really tough to find digital representations for that. So, number one, we are able to do. Number two, cloud representations are already a lack, and apps that make value out of that are subsequently not available. That's a tricky point in industry and society, and AutomationML is now going to tackle this problem for engineering data. And now we come to the future of AutomationML. We have invented two major concepts to overcome the problem. Our analysis shows we have to answer two major questions. What you see here is the ChatGPT library with properties that are useful in engineering. The first key question is, how can we publish AML models globally? For this, we need a distribution technology. We need a publication process. We need a quality assurance process. We need a nice versioning concept. We need a concept for flexible workflows, for different workflows. We want to make AML models searchable, findable, and easily reusable. And second question is, how can we improve the semantic capabilities of AutomationML? Semantic capabilities mean, how can we make AML attributes themselves semantically referenceable? How can we enable third-party software to map their own proprietary terminology to published AML types? How can we interconnect semantic libraries with one another and build bridges between existing standards and between different terminologies? How can we enable companies to exchange data even with heterogeneous models? Imagine one company is using some proprietary data models, a second one is using the IC CDD, and the third one is using E-class. How can we enable companies to still exchange data even if they have no common data model? And analysis number two is, there are lots of definitions for everything. For the dimensions and volumes and for the lengths and width and force and voltage and everything. And if we look into DIN standards, we find definitions for what's an actuator, what's a drive, what's a pipe, what's an adjusted nominal pipe size. It's all there. But how can I access that? How can I make that referential somehow? The IEC CDD provides an IRID. The E-class has some semantic identifier, but where do I find them? I have to go to a website, or I have to become a member, and then I have to copy that somewhere. And but can my software then access this to find out what an actuator is? No. But this would be the basis of data exchange. We need an equal understanding of features, of terminologies, of objects. We need to have the same scope and the same interpretation. Standardization is key, of course, but the standardization of terminology therefore has not been successful so far. And now our first new feature is AML Library Spaces. What is an AML library space? Mainly, an AML library space is conceptually a common space for AML information models that can be found in the internet. It's a secure, virtual and physical location used to store and organize and share AML models or documents with authorized recipients. We have a low technological overhead, so we don't sell you server space. You can use your existing IT infrastructure, or you can set up one based on available freeware. You have no vendor dependency. We have a standardized syntax. We want to make the AML models available, searchable, explorable, and referenceable. And we want to protect the data through signature. It's in the library space. Technically, if you look at it from the technical side, it's just a server. It may be a folder on your hard drive. You can have your own library space on your hard disk just for testing purposes. And the setup of that takes 5 minutes. Or it could be a cloud storage. It could be your network folder. It could be some cloud storage you already have, or you can set up a new one if you want. It is technically, it could be RAM. It's somehow connected to the internet, and it's an implementation concept how to use it all together. In summary, it means we take this library and we publish it in an AML library space, and from here it gets globally available to the community and whoever wants to see that. The second new feature I want to introduce is the AML ID. And I would like to explain the AML ID by means of an example. We have talked about Equinor. We have talked about the SCD model. And one attribute in the whole SCD model is the property type signal class. It's just a type that they defined. The idea is that this gets a semantic identifier that will never change. Then we publish this in an AML library space so that everybody has access to the SCD data model with this property type signal class. And then we have different use cases. Engineering tool number 1, for instance, has the option to take over the SCD terminology, or the second option is to keep the own terminology, which is already baked into the engineering tool number 1, but to map it to the AML ID. So if they don't name it signal class, but they name it differently, so they can add a mapping to the AML ID to get it a semantic reference. Now imagine another engineering tool has an own terminology that is already mapped to IC/CDD. Looks like a conflict. What is leading? Is now the AML semantic leading, or is the IC/CDD leading? We want to solve this conflict. And for this, we provide the following functionality. With standard means of AutomationML, we extend this library with a semantic reference to the CDD term signal class whenever it would be available. That means that the standard property here that has an AML ID has itself a semantic reference to the CDD term. This means that the engineering tool number 2, if it receives an AutomationML file with the SCD property type signal class, can see that it's connected to a CDD term and can make use of that. And then we have another case. Engineering tool number 3 is addicted to E-class. Do we have another conflict? No, we don't, because AutomationML properties can also be referenced to the E-class term signal class if this would be available, and it would likely have another name or another identifier, but you understand the idea. With this concept, we want to build bridges. We want that engineering tool 2, which is using the IC/CDD, and engineering tool 3, that is using the E-class terminology, don't need to change. They still can exchange data with one another by using the AML ID, which would then bind these different terminologies together. This is the major idea behind that. To summarize the concept, I want to publish libraries in the cloud. Every attribute type gets a unique and stable semantic ID. Because it's in the AML library space, it's internet enabled and searchable and findable. And then the meaning of an attribute can be explored digitally. I give you a demo how to do that. And thus proprietary models can reference this semantic ID to break the proprietary character, to make it semantically explorable. We want to bake the semantics of an attribute directly into the model so that software can automatically find out what an unknown attribute means. And we explicitly allow that the length or the speed or whatever attribute we think about is defined multiple times in all these different standards, because they can interlink with one another and have their right to be there. And if there is a need to shrink this a little bit, if duplicates are disturbing, then the standardization process can be initiated wherever it's needed. We don't have to wait for the final standard to be done. We can start with all these unsharp situations, and we can live with that. AML ID is designed for organic growth. You don't need to wait until you have a final golden standard available, and you can just start with a library and you can put it into business. And this solves the conflict between the long waves of standardization, which we need, and the short-term project pressure that we have if we want to solve problems now. The technical concept is shown here in a more technical figure. What you see here is the cloud with a library and a published attribute direction, which has an ID. And via a semantic reference, you can define your proprietary property, and you can give it an etiquette by referencing this AML ID. And so you have modeled the semantics. It's very easy. This is how it looks like in the AutomationML Editor. And I think now it's time for a tool demo. I will give you a short tool demo so that you can directly see how it works. So what I'm going to do now is I have prepared 2 libraries and I have an empty AML library space. I show you what I have prepared here. What you see is I have a little library here. It contains just 3 attributes. It's Länge, Breite and Höhe, which is length, width and height. And here in the header, you can see a description, what it is, what it means. And that's mainly all. Let's publish that. File, publish. Here I select the AML library space where I want to publish that. I use this one. I press check. I press publish. And then he's doing some work, and now it's published. Now it's done. Let's repeat that. I have prepared another one. This library is a little bit more comprehensive. It's made by ChatGPT. It bases on the ChatGPT model that you have seen so far. I've extended it a little bit for different purposes, color physics, electrics, and I would wish that the Dean or the Physikalisch-Technische Bundesanstalt would develop such a library and publish that. And they all have an ID. This is an ID here. And I'm going to publish this library into my library space. Check, publish, start, done. Now I have two libraries in the cloud. What can I do now? Let's do some interesting work with that. I want to model my product catalog. And I have a robot here. And I want this robot to have a length. What can I do now? What I usually do then is I develop my own library. I say this is my attribute type library. And here I define my private links. So this is an attribute. I instantiate it here. So, and now I have my private links. I'm going to store this in my folder. I call it P0. It's my demo project P0. Now it's all proprietary. How can I make use of the library space now? So I show you different approaches. Approach number one is if I know which library I want to add, then I can add a reference to the library space manually. Here I find my master class library, I add a reference. Nothing has changed in my document. My document is now not blown up with all the classes of that external library. It's still empty, but it has a reference to this external library. And I can switch to this external library, and now I can use the published attribute here. I make an instance of that, and now you see I have an attribute for the private length and I have an attribute for the published length that is in the cloud. So there is a third option. If I don't know where the library are that I want to, then I can just find it. Here I can find attributes on my space. For instance, now I want something with physics. I want a speed. Speed, nice. What was speed? I press the info button, it investigates the meaning of that attribute, and he finds out it's the rate in which an object covers distance measured in the magnitude of velocity, typically meters per second. This is what I want. This now makes a reference for me, and I call it V. Now I have used my private lengths, I have used the published length, and I have used my speed from the second library. And now I want to show you how can I deal with this private length. Look at here, this is my private attribute. How can I bake the meaning into the model? Very easy. I go to find attribute type online. So then I start searching, and then I find, oh, there's two types of lengths. I'm a length type and I'm a length. I'm going to use this one. I can inform myself, is it what I want? Yes, it is what I want. It's this library. And then I add a semantic reference. And that is really nice. Now I have a mapping of my private property directly baked into the model because it now has a semantic reference here to the AML ID of the published library. And here I can press the check mark, and then he will tell me what it means. So this means that every application of this private property is now electronically investigatable. So a software can inform itself what that means. So I model a station, and I'm going to add some instances here. So I have 3 robots that somehow use this. So let's close this. I have a project. What can we do now? The most interesting thing now is about versioning. I want to develop a new version of one of these libraries. For this, I select the library I want to make a new version from. I press create new version. And this dialogs help me to name the version. Then I make a new folder for this version, and I'm going to save that. So I want to add an attribute, for instance, a volume. And I have broken 2 rules to model a library. The first rule is that the attribute type should have a description, and it should not start with a capitalized letter. I'm still going to publish that. And with the check button here, you see that now a check engine is checking all the different guidelines, and he finds out that the volume is somehow wrong. And he helps me to correct that. I press the button and it's corrected. And if the description is missing, this is a volume. And I can recheck. Now everything is fine, and I can publish that. That's all. And now I have 2 versions of that. And you can see these 2 versions in the relations diagram. You see there is a version 1 and a version 1.0.1. Let's do it again. It's really fun. Edit, create new version. I make a 1.0. I create a new folder, 1.0.2. I save it and I add even another attribute which I name space. I add a description to that. This is a space just to avoid problems here. And I'm going to publish that. I check it, I publish it, and I start it, and I'm done. So now you see that I have a third version available here in the row, and I could make another version of 1.1, and then we would have a branch, and then we can cluster it and bring complex version trees here. But the key question is now, what is now happening with the project? I show you. While opening the project, he's seeing that the library that is referenced itself has a new version, and he's providing me to upgrade. I say no, just to show you what's going on in the background. I will make this library visible for you, just to give you an insight. Here we still have the old version, the first version 1.0.0 here referenced, and we can still make use of that. But when I upgrade, then I check for the new library versions, and I can select one of these, and I select 1.0.1 and I do the upgrade. What's happening in the background? I have changed the library in the background. Everything else is still working. So we have the volume. And if I do another upgrade, then I can select the latest version. I do the upgrade. I say yes. And you see that now he's using the latest version with this space. What we have learned is you can develop own libraries. You can publish them and make them available. You can make use of that. You can use the published library to take proprietary libraries with the standardized semantics to make the machine understandable. And you can create new versions and you get to upgrade functionality. And there's much, much more. And conceptually, I now switch back to the slides to show you a little bit more about the application of that. Application. We believe that the future will be cloudy. The idea that we will have in future one semantic cloud with one world model that we all agree on is not reachable. The AutomationML Association has an AML library space that is already publicly available. You can use it right now. I hope that the Dean will publish a Dean library space with Dean content. For instance, together with the PTB, with the Physikalisch-Technische Bundesanstalt Braunschweig-Berlin, they could publish all the SE units just in this way. It would be so helpful there. I would like to invite eClass to publish their property lists into a library space. We do not want to be in a competition with eClass. eClass is a valuable story, and they are invited to make added value with their property lists by making them available digitally. And the CDD is, the IC is invited to publish their CDD library space, and Siemens can do it, and the SCD libraries could be published, and the DEXB library could be published, and many, many more. And there is no need to publish them globally. You also enable to publish them to an authorized community that you want. Maybe your customers, your partners. So, and based on this, we have different use cases to realistically interconnect standards. The first one is towards standardization 4.0. We want to make global standards become digitally referenceable on the conceptual level among each other. We want that an AML library space, the lengths we define here could be interconnected with the DIN length and with the eClass length and with the CDD length. And on the other hand, we want that companies should not be forced to switch from grown and evolved terminology. We just say, keep your terminology as you are used to. If the French guys want to use French terminology, and Siemens and Audi and KUKA and Equinor, and they all have their own grown terminology, they are invited to keep it, but add mappings to the standard terminology. That's the idea. And thus the data become automatically explorable for partners in their meaning, even if the data that you receive are not originally using the same terminology that you use. You can still explore what they mean digitally. That means engineering tools, ordering tools, data sheets, and whatever tools can exchange data, even when the engineering tool is using eClass, the ordering tool is using CDD, and the data sheet is using something different. So they can still find out what it means. And based on these ideas, we get new business models. And the first set of business models is the open source. Our AML standard libraries are just freely available. You can just download them. I invite the Dean to publish free standard libraries for basic properties like length. You can use free deployment technologies like WebDAV, Nextcloud to technically implement the ML data space. I think that domain libraries may occur that are freely available. Even dictionaries and ontologies can provide their content on open source base. And it's a wonderful testbed for academia and pre-development. And the value proposition, it can be implemented in days. We believe that the standardized availability of models and terminology is first time. It's an incubator for ideas and use cases. It's low cost, low tech. It's low risk and it's PhD free. You can use it within a day, even if you are a single man company. But how can somebody earn money with that? There are more business models. One of them are the commercial library spaces. It might be that you do not want to host a library space by yourself. You can ask Microsoft, SAP, and Amazon to do that for you. Or you are invited to self-host library spaces for your partners and customers to provide added value. This is interesting, especially for small and medium-sized enterprises who first want to go initial steps with the existing technology and IT infrastructure they have without hiring another IT department. Or semantic owners like E-Class and Dean, who have their own business in selling standards, can use library spaces in a commercial way and give access based on a payment plan. The value proposition of that would be a professional environment, professional reliability and availability with exclusive benefits for partners, with customer binding and so on. And of course, not mentioned so far, the apps, all the apps behind that. Think about the petrol station apps. There could be apps to provide tool-supported workflows, document management, data calculation, visualization and documentation, impact analysis, interconnection, white spot analysis, user management. I think building bridges will be a big business in future if you have all these clouds together, and migration support. And the value proposition here is to sell risk, to minimize risk, to identify quality issues, to automate data exchange with high quality, and to connect tool chains. Especially the migration support, which is here written in bold, is an example that I want to elaborate a little bit more because I think there is an interesting business case in that. Imagine somebody has purchased an automation component. It's a smart component with 500 parameters. They are fine-tuned, the system is running, everything's fine. But 2 years later, it's broken and the device must be replaced. But the new type within the same component manufacturer, the new type of automation component has now 550 parameters, 300 are identical, but 30 are renamed and 70 are new and some are deleted, and you are in a mess. A migration path is unclear here. Or even worse, after 10 years, the device is broken and must be replaced. Then you have skipped 5 generations and the new device has 600 parameters and only 100 of them are still the same. And the majority is new or renamed or deleted and you are in a mess. And imagine you don't have only one device, but 100 or 1,000 devices to be replaced. You are in a mess. It's a technological problem. So the price for the migration of all these parameters might be more expensive than the device. That's why people don't do it. They just intend to stretch using these devices until the end of their life. And this is an investment hurdle. How to solve this here? The idea here is with AutomationML, we would make an AutomationML class for this version. We would make an AutomationML class for this version with all the parameters as they are defined. And then there would appear within this vendor, the vendor would develop a manufacturer's own attribute typelet with an AML ID concept. And then you can tag all these different attributes. And then every attribute knows what it means. And even if it's renamed by adding the AML ID, it's clear what that means. This allows that you can close the gaps automatically and you can automatically generate the migration path. You know exactly which parameters can you take over, which are new and which are just renamed. At least you have a guidance. And from version to version, this interconnected model becomes richer and more valuable. And the business model, of course, is then the automatic generation of migration paths. Could be automatic and reliable based on the models. And this use case becomes even stronger because the more complex the version history is, the stronger is the business case. Look at here. If somebody has a device version 1.00 and want to update to 1.22, just pick two of them. It would be to simplify the migration, to then finally to simplify the investment and to reduce the migration hurdles for the customers. And by the way, the hurdles get greater and greater for a system that is larger and larger. And so is the business. And an automatic generation of migration passes from any version to any other version, device by device, is, I think, an interesting use case for component vendors. So it's suitable for arbitrary complexity and for any number of devices, and it scales from small to large systems. This is a business idea that should inspire you to think about what else can we do with that. So AML libraries in practice. How can we use that in practice? It's very easy. First, you need a useful AML data model. If you don't have one, it's not your business. If you have a pain point in data exchange and you develop a data model, then you are on the board, and then you create a library space. You publish your model, including access rights to an authorized team or globally, and then you apply the data model. You do data exchange, you provide search and find, and you can reuse data models, you can reference semantics. And to be very clear, it's very obvious that you will collect ideas for improvements by applying it, and then you go to step number one. And this breaks a typical deadlock in standardization. The typical deadlock in standardization is not finalized because it lacks feedback from its application, and the application doesn't happen because the tool vendors wait for the final standards. And this concept breaks this Gordon knot. You just get into business by this. You start a spiral of development and standardization. AML libraries, therefore, provide an extensive version management. You already have seen this, but in reality, it will look a little bit more like this. This is not hand-drawn. This is directly built from the AutomationML Editor in a more complex situation. So how is the publication process? We thought about the publication process. It's a sensitive step. It must be flexible. It must be secure. We want to support AML hosted spaces, self-hosted spaces, external hosted spaces, local test spaces. We want to provide security and authorization without adding another security layer to the security layer you already have in your company. We want to secure that the AML libraries that are published have a high quality. We need a library development guideline. We need quality checks, possibly automatic checks with repair mechanisms, and we distinguish between errors and warnings. And the publication should be guided, traceable, and reliable. We need guidance, visual feedback, backup functionality, undo, restore, and a server management functionality like server switch. Typical error scenarios should then be automatically detected and handled. A very typical example is that somebody tries to publish a library that is already published, or if somebody wants to delete an already published library that already has a newer version, that should be handled. So, and this is our publication process. Don't worry, I will not explain you all these different steps. You should just get an impression that it's well thought and it's there. And how is the library development process? For this, we have developed a library development guideline. It's not long, it's not 200 pages, it's about 22 pages. We have conventions, how to name an AML library, how to name an AML file, how to name classes, what are the conventions for structuring libraries and for modeling libraries, for modeling extensions, how to version libraries, how to self-identify libraries, how to sign libraries, and recommendations for the online application, and so on. It's all well defined. And one of the key properties is that if you have a new version of a library, the new version knows where the old version is, and the old version knows where the new version is. And this is not only limited to libraries, it's also available on class level. Every little class knows where the previous version is. I showed to you. Here is version 1.0.2. And you see here there is a revision field that points to the old version. And this is class by class. Yeah, and this is the newest version. If you hover over it, this is already the most recent version. And this one has no predecessor. It's just a new one. So they interlink with one another. This means that all the versioning information is baked into the model. It's not baked into some database somewhere. which you cannot read anymore if your expert is leaving the company. It's baked into the model, and you can take the model and take it with you, put it in a safe, and all the data is still there in 20 years. That is what I name investment protection. Just to give you an idea of what the guidelines mean, what you see here is the original SCD library in the current version. You see just a list of libraries. By the way, it's too long, it's too many classes to show you everything. But if I apply the guidelines, then you see we have strict guideline rules now. Here we have a prefix that should identify the owner, and then we have the domain and subdomains, and then we have the library name, and we always request a version number. So it's by far not done. The steps to improve the SCD library according to the modeling guidelines is all classes need a description and a version and an identifier, which is not there in the original library. All libraries and even the file should follow the naming conventions. This is what I've solved already. All attributes get a dedicated type with a semantic AML ID. This is not the case today. It's around 1,900 attributes that have no type, and this should be changed. The library should then be published in an AML library space and would then be available through the AML Editor. How would that be? Here I'm going to show you how to do that. Here I switch to our AML release server, and here you see our AML libraries, and here would then be the SCD space to find it and to reference it and to make use of that, and then you can use it in the way I showed you. How is the workflow? How can we support different library development workflows? I think the most obvious workflow is you have one user, one owner, which just creates a library. He is doing all the modifications, he's reviewing it, testing it, finalizing it, documented, and he initiated the publishing process, and that's it. Now here you have a lot of work with documentation and fine finalization, and then you publish it, and now it's available. Then people can use it. By the way, it gets a signature here, and the signature leads to the situation that if somebody here on this side is manipulating the library, then the signature is broken, and then there's a healing mechanism that automatically finds out that there is a library that is broken, and then you can replace it by the original, just as a self-healing process. A little bit more tricky is if you have a team. The team is not changing much. You have one owner. He is the owner, and he's the only one with publication authority. He's creating the initial library together with the team. They all are doing the modifications and the review, test, and documentation. And finally, you see it's very similar, but now it's with a team. So next step in complexity is you really have a team, and you have a public space and you have a test space. You don't want to send the AML libraries via email around. Then you do the following. Peter starts with version 1. He's doing the modifications, and he's going to publish version 1.01. Then Susan is downloading the latest, is doing modifications, is publishing the next version. And then Peter is starting to download the latest check-in, check-out procedure, as we know from GitHub. He is going to download, modify, and publish. By the way, in comparison to GitHub, we don't have merge functionality. GitHub is developed for daily work with many people on the same code. That's why you need merging. Library development is a rare place that you do likely every 2 years. So we don't see a strong need in merging. If you need merging, then you need additional software functionality, and possibly an AML library space could also be a GitHub server. We have not tested it, but conceptually there is nothing against that. Then you download the latest review and publish the AML lib. So this is a development process for a team and a test server for a first version. How is the workflow for a new version? It's not that difficult compared to what we have heard so far. You have an already published library. From here, you create a new version as an owner. You do the modifications, you review, test, finalize, and document it, and then you publish your new version. And then we modify both versions. So this version is then modified. All the forward references to the new libraries are entered into the model, and all the backward references to the previous version are baked into that. And then it gets a new signature. By the way, it then has 2 signatures. The old signature is still alive, and the new signature is also alive, so that people which are still using this old version can still live with it, and people that gets an update to this version will see no change. Let's talk about quality. I have written each and every single rule in our convention guideline into an Excel sheet, and I checked each and everything together with the development team of the AutomationML Editor to automate it. And we have done it. We found out that some of the rules are not checkable. Some recommendations are so a little bit fluffy. For instance, here's a recommendation that you should use attribute types whenever they are available. Don't invent new attributes. This you cannot prove. It's a recommendation for the humans, but most of them are checkable and they are all checkable. And all this is available with the new AutomationML Editor 6.4, which is available, and it has a couple of new functionality. It provides comprehensive version support with linear version chains, with version branches, version trees, with mutual forward, backward referencing directly in the model, with extensions, examples, and collections, and with a visualization of version dependencies. We have a publication process with quality checks and repair mechanisms before publication, with mutual referencing of published clips during the publication directly in the model. There are no external dependencies, and we sign the published libraries after publication to protect them from manipulations. We have functionality for AML Library Space Management. That means we have profiles for secure access and write management. We have functionality for relocation, recalculation, unpublishing, redo, backup, and restore. It's all there in the AML Editor. And we have online features with the AML ID where you can find semantics, where you can add semantic references, where you can browse, reuse, and reference and investigate models. And we support a distributed library architecture. So we go away from merging all libraries into one huge AML file. We keep all the published libraries separate and just to maintain the ownership. And we have offline support. So if you are suddenly offline, you still can continue work with the AML Editor. It's available immediately. You find it on the website, the AutomationML community. So now, therefore, we open it for everyone. There is a free, a pro and premium version. The free version is you can just download and use. It has most of the functions, but it's limited in the modeling size. We have a campus license for the academia with a very reasonable pricing. You can use it for as many students you have in your university. Since we are not a company, we have not a big business model behind that. So don't be afraid. It's reasonable pricing which helps us as an association to continue with the development of our AML editor. All the details you find here on the website that is shown. So in summary, what have we achieved? We wanted to achieve a methodology that makes AML models digitally available, done via AML Library Spaces. We wanted a methodology to make models machine understandable. We have the AML ID and we have the classic role concept for semantic identification. We wanted a standardized manufacturer independent technology open approach. We use AML as it is. We have not changed AML. It's an IC standard. We wanted to have something that is business compatible. It is from open source to hardcore business models. We wanted to have something that is sustainable and stable, XML-based, document-based syntax. We wanted something with versioning, signing, and update mechanisms. It's all baked into the models. We want to have flexible workflows. I have shown you some. We want to have a freely selectable technology overhead. It's fulfilled. Yeah, you can use your own AML library space with the infrastructure you already have. Or if you don't have it, then you find free technology to use it like Nextcloud. It's suitable for SMEs, and that's important. We do not only want to address the big companies, we also want to enable the small and medium-sized enterprises to look into that, because it can be understood and it can be implemented by a single person in very short time. It's PhD free, can be learned quickly, and it's cost effective. Thank you very much for your attention, and if you have further questions, please contact me.